Learning target 5.6 is being able to find the exact values for the 6 trigonometric functions of special angles. And these are going to be the angles that I told you to memorize earlier. They're the multiples of 45 degrees and the multiples of 30 degrees. And you'll also be able to find decimal approximations for these values. But you should be able to do this without the use of a calculator. So finding those exact values you can do without typing in and figuring out approximately that decimal value. For example, if I asked you to find the values of the 6 trig functions for an angle in standard position that measures 90 degrees, I know that 90 degrees is right there, and so I've got the value of 0, 1. And so we talked about this in the previous learning target, that sine is associated with the y value. So if I said, what is the sine of 90 degrees? Your answer would be the y value of that coordinate, which happens to be 1. The cosine value of an angle is the x value, and so because the x value is 0, the cosine of 90 degrees is 0, and the tangent of 90 degrees is the y value over the x value, so it would be sine over cosine, or 1 over 0, which we would say is undefined. And I believe if you try to type in the tangent of 90 degrees and your calculator is set to the degree mode, you would end up with an undefined answer, an error. So if you use that concept to complete the rest of the table, we can start by filling in this block with a degree measure of 90 degrees. By the way, that would be pi over 2. And the sine is 1, cosine is 0, and the tangent is undefined. Cosecant, secant, and cotangent are the reciprocals of these 3 functions. So the cosecant would be 1. The tangent, or the secant is the reciprocal of 0. So instead of cosine being 0 over 1, it would be 1 over 0, which is an undefined value. And cotangent, even though it started off as undefined, because it was 1 over 0, if we flip that over and have the reciprocal, it becomes 0 over 1, or just 0. If we wanted to complete the table for the rest of the values, we can do that. I'm going to walk you through it for the start of 180, and then I'll just fill in the rest of the table. But if you want to pause it before you copy it down and see if you can try some of the values on your own, I would encourage you to do that. So 180 degrees, again, let's remind ourselves, would be right over here. And so we need to know what are the coordinates of that point. Well, because the radius is 1, that point is negative 1, 0. So the sine is associated with the y value. Cosine is associated with the x value. Whoops, I'm filling these in the wrong spot. 180 degrees right here. The sine value is 0, and the cosine value is the x value, or negative 1. If you remind yourself, the radians for that would just be pi. And the tangent is going to be y over x. So it's 0 over negative 1, or just 0. Cosecant of 180 degrees is going to be the reciprocal of sine. So instead of 0 being on the top, 0 will be on the bottom, which makes that an undefined value. The secant is the reciprocal of cosine. And so because that was negative 1 over 1, we can flip it over and it would be 1 over negative 1. It still gives us a value of negative 1. And the cotangent, again, because cotangent is the reciprocal of tangent, and because it was 0, we would flip that over and it would be on the denominator, which would make that value undefined as well. Okay. So if you want to pause, try to fill out the rest of the table for 0 degrees and 270, and then continue, and you can compare with my completed table of 0. Let's see. 0, sine is 0, cosine 1, 0, undefined, 1, and undefined, and then for 270 degrees would be this point right here of 0, -1. A radian measure of 3/2 pi, or 3 pi over 2. And we can fill in so you can compare that with your own table, and maybe you'll notice a pattern that when the tangent is undefined, like it was for 90 degrees, so is the secant. When the tangent was undefined, so is the secant. And same goes for when the cosecant was undefined, so is the cotangent. That's because you end up with the same value of 0 being in the denominator. Okay. So I said we were going to be doing this by hand, memorization for the special angles, so the 30, 60, 90, 120, 150, 180, any multiple of 30, and then same with 45, 45. We want to look for anything special that happens with the 30, 60, 90 triangle. So again, you could, with this drawing, you could imagine like the XY axis being right here. And this would be the angle theta. I've got the mirror image drawn up here for a reason, and that is because if we're using this as our radius, we want to treat that as 1 because we're going on the unit circle. That would mean that if I've got the mirror image, I've got a 60-degree angle down here, I've got a 30-degree angle down here, and that bigger triangle is an equilateral triangle. So all 3 sides are the same length, all 3 angles are the same measure, and so I could say that this entire measure right here would have to also be 1 unit long, which would make this side exactly 1/2 of a unit, so that would be 1/2, and that piece would be 1/2. And so now we have to figure out, well, what about this measure? What about the adjacent side to a 30-degree angle? How long does that have to be? Well, it's going to have to be somewhere in between 1/2 and 1, because it's a little bit longer than the side labeled 1/2, but it's a little bit shorter than the hypotenuse. So we can do some calculations and figure out how long does that side have to be. Using that same equation that says the radius equals the square root of x squared plus y squared. I know the radius is 1. I don't know my x value, but I do know my y value is 1/2. So I want to square both sides. I still end up with 1, but now I got rid of my square root, so I have got x squared plus 1/2 squared, and so that squared can go to both. Or you could type it into your calculator and you'd get the answer of 0.25. Turn that into a fraction, it's 1/4. So I have to subtract 1/4 from both sides. And I end up with x squared equals, what's 1 minus 1/4? That's going to get me 3/4. So now to solve for that length of x, I take the square root of both sides. And I end up with x equals the square root of 3/4. Remember when we simplified radicals, we could split that up and say it's the square root of 3 over the square root of 4? Well, that's nice because the square root of 4 happens to be exactly 2. So that means that that adjacent side has to be exactly square root of 3 over 2. Okay. So now if we kind of erase some of those measures that we needed to get there, and we look back at this unit circle being drawn there, and this is my angle theta. Okay. First of all, we can convert 30 degrees to pi over 6, and now we can look at those 3 main trig functions, sine, cosine, and tangent. So sine of theta is this opposite side, or the y value, over the hypotenuse. So it's going to be 1/2 over 1, or just 1/2. You can double check that. Type into your calculator either the sine of 30 or the sine of pi over 6, depending on which mode your calculator is set to, and make sure that the sine of 30 degrees really is 0.5. Then we can look at what the cosine value is. And the cosine of an angle is the adjacent side over hypotenuse. So it is going to be the square root of 3 over 2 over 1. We don't really have to write that. And if you type in, well, what is the square root of 3 over 2? Square root of 3 over 2, when I type that in my calculator, is about 0.866. And I can double check that when I type in the cosine of 30 degrees, my calculator gives me the exact same decimal answer. It is 0.866. The decimal continues. Now, how do I get the tangent of that 30-degree angle? Well, the tangent is going to be my opposite side over my adjacent. So I know that the tangent of 30 is going to have to be 1/2 over square root of 3 over 2. And so now we have to remember our rules for dividing fractions. When you divide by a fraction, you want to multiply by the reciprocal. So that's the same thing as taking 1/2 times the reciprocal. And I could write that as square root of, or 2 over the square root of 3. So I just took this fraction down here and I multiplied by the reciprocal. So what do we get there? We've got 2 over 2 square roots of 3. Okay. That would be a good answer, but I can simplify it a little bit. For example, I know that my 2's can cancel. So I've got 1 square root of 3. And I also don't like that square root in the bottom, so I want to get rid of that by multiplying by the square root of 3 over the square root of 3, which becomes the square root of 3 over 3. That is my answer for the tangent of a 30-degree angle. 60-degree angle is going to just be looking at it from this other angle. So if I use this as my angle, now my opposite and my adjacent sides flip-flop. So now this side becomes my opposite, and this side becomes my adjacent. And we can look at the sine, cosine, and tangent values of that 60-degree angle. So if I was going to convert that to radians, it would be pi over 3. The sine is opposite over hypotenuse, so it's going to be square root of 3 over 2. Cosine is adjacent. Now this side is adjacent, so it would be 1/2 over 1. And then the tangent is the opposite over the adjacent. So now I've got this problem with my fractions again. So I have to write that as, I'll write this out first. The tangent of a 60-degree angle is going to be my opposite side over my adjacent side, but I already know that I'm not going to want to divide by 1/2. I would rather multiply by 2 over 1, multiply by the reciprocals. This one's actually a little bit easier. We just get the square root of 3 over 1, the square root of 3, for the tangent of 60. Okay. On the next page then, actually, I'm going to pause it there and start a new video for part 2.